Okay, so today I want to go through how to do a problem, a nice problem, when coefficients are involved. We're still dealing with a very small k value, so as to avoid using the quadratic equation just yet. So the equation or the problem that I have is that at a particular temperature, K equals 4.0 times 10 to the negative 6 for the reaction to carbon dioxide gas yields to carbon monoxide gas plus oxygen gas. If 2.0 moles of carbon dioxide is initially placed in a 5.0 liter container, calculate the equilibrium concentrations of all species. So first thing we're going to do is we're going to set up our ice table. Now again, I know this is going to move from left to right or from reactants to products because there is no value for the products at this point. So I've drawn out an ice table and I filled in what I know so far. So I know that there is 2.0 moles of carbon dioxide in a 5.0 liter container, and if you do the math on that, it gives you 0.40 molar. And then for carbon monoxide, there's 0 molar, and oxygen, there's 0 molar. Now here's where the coefficients come in. Because there's 2 carbon dioxide, it's not just going to be minus x, but at this point in time, it becomes minus 2x. And because carbon monoxide has a coefficient of 2, it's going to be plus 2x. Now oxygen is just going to be x because there was no coefficient in front of it. So for our equilibrium concentrations, we have 0.40 molar minus 2x, 0 molar plus 2x, and 0 molar plus x, and we'll fill in the final after we do the math. So how the setup looks is this. So we know K is 2.0 times 10 to the minus 6th. And we know that we're looking at carbon monoxide squared because the coefficient was 2 times oxygen all over carbon dioxide, and that's also squared because of the coefficient. So what we're going to make the assumption is that x is going to be fairly small in this case again. So if we looked at what the values were, we would substitute in here 2x squared times x all over 0.40 molar minus 2x, and that's also going to be squared. Okay, so what we're going to say is that this value down here is going to be really, really small because our K value is still very small. So how our equation is going to look at this point is this. We're going to have 2.0 times 10 to the minus 6th, and that's going to equal 4x cubed all over approximately, and usually when we show approximation, we just squiggle the equal sign to show that it's not really equals, but it's approximately equals 0.40 molar squared. Okay, so if we simplified that again, we would still have 4x cubed, and it's going to be over 0.16 molar. So at this point in time, if you went and did the work and solve for x, and if you need help with that, I can work with you separate. So x is going to equal 4.3 times 10 to the negative 3rd molar. So just to make sure you understand it, you're doing the 2.0 to the negative 6th times the 0.16, dividing it by 4, and then taking the cube root of that. Now we need to do our check to make sure we are within 5%, because if it's outside of 5%, we would have to use quadratic equation. So you're going to take your 4.3, 10 to the minus third molar over your initial concentration, which was 0.40 molar. And if you do that math, you get, actually you got to do here, because we had the 2 in front of the coefficient, or the coefficient of 2 in front of the problem. You have to do 2 times that concentration all over 0.40, the whole thing times 100, and you're going to get 2.2%, which is within the assumption. So that works for our 5% rule. So you would go back to your ICE table and take off the values to get your final concentrations. So for carbon dioxide, you're going to have 0.40 molar, and you're going to take off, 2 times 4.3 times 10 to the negative third molar, and that's going to give you a final concentration of 0.39 molar. And for carbon monoxide, you're going to have 2 times 4.3 times 10 to the negative 3 molar, because it was 2 times x. So you're going to have 8.6 times 10 to the negative 3 molar. And for oxygen, because it was just equal to x, it's just 4.3 times 10 to the minus 3 molar. So the 0.39, the 8.6 to the minus third, and the 4.3, these are the actual answers to the problem. So I'm going to give you a problem to do on your own. This next problem that you have is going to have information not only about the reactant, but it's going to have a concentration of one of the products. The reaction, just so that you don't have to try and guess, is going to go to the right. When you fill out your ICE table, instead of the concentrations of both products being 0, you will have a concentration of one of the products to fit into your ICE table. If you have any problems or issues with this, please just send me an email or a message, and I will try to help you through the problem. After you're done with the work, upload it and submit it for your work for the day. Have a great day.